Hello, my name is Paul and I enjoy talking about technology in general and software development in particular. Today we're going to look at server-sent events from a Spring Boot service to a web page. So let's jump in and see what that's all about. What are server-sent events? Server-sent events are the ability for a server to send a stream of events via HTTP back to a web page. So the use case for this is if, for example, we have updating content that's updating in real time. It could be a chat session between multiple users. It could be locations of cars on a map that are updating in real time. Updating dashboards with real-time analytics and so forth. There's lots of use cases for this. So how does it work? It's actually fairly simple. It's triggered from the web page, which sends a GET request to the server, the specified endpoint on the server, and it's saying that it'll say that it accepts a text/event stream content in return. And then the server will respond with a success, a 200 status message, and it'll return with the requested text event stream. It'll usually say in the header of the response that there'll be no cache, because we usually don't want to be caching real-time updated content. And importantly, we'll usually have a keep alive header on the response as well, so that the connection will stay open between the client and the server. And then as the body of the response, we'll be getting a stream of text data. And you can imagine a stream of text data as like a text document that's slowly downloading to your browser, even though it's being dynamically generated on the server side. Okay, so let's look at what the response body would look like. The format of an SSE event stream is like a text document slowly downloading. Text format protocol, so there's no complicated binary data in there. Lines of this document that begin with a colon are just comment. You separate each individual event that is sent. There'll be just 2 new lines. There can be several fields in an event, which just have a field name followed by a colon and then a space and then the value of that field. And some common fields that you might have will be data. I think that's mandatory because that's the content of your event. It can have an ID, although that's optional, but the ID is pretty useful, and it can have an event field, which holds the type of the event, and you can define your own types as per the requirements of your application. So looking at the 3 examples I have here, there's a comment test stream. This is a comment. You've got data first event with an ID, and then the second example has a comment and followed by 2 events, and then followed by a third event which has a 2-line multi-line event, so you can have multiple lines of data in the event, and the third one shows an event type. So we could have, for example, new user added to conversation, or car has just a reach destination event, or something like that, as per your application's needs. Okay, so as we know, connections on the internet are not always stable, and so we need a mechanism in place so that if we lose connection to the server, the client can in some way request the events that it missed whilst it was offline. So this mechanism is quite simple. All we do is we repeat the initial GET request to the SSE endpoint, and included in that GET request we include the header last event ID.
and the ID of the last event that we received. Now, this obviously only works if you're including IDs in your stream. If not, then this mechanism won't be available to you. But let's say we're numbering our events 1, 2, 3, 4, 5, and we receive event number 5, and then we lose connection to the server, and then sometime later we reconnect, and we can then say, get me the stream of events, and the last event I received was 5, and then it's up to the server to return a response with the data that you missed. And so it'll return a 200 response, and it'll send you it'll look up what events you missed and return those to you if it's properly implemented.
So there's a JavaScript interface defined for interacting with server-side event sources with the event source object, and so you simply create the event source and pass it the URL that you're going to be receiving these events from, and then it'll give you a callback whenever an event is received. So the responsibility for this event source object includes reconnecting if there's a connection failure, and also you can set up some configuration in an optional options parameter, second parameter to the constructor, to set things like timeout intervals and so forth. Okay, so within Spring Boot, even though this is a very simple protocol, and we can probably imagine writing our own support for it, just using a Java servlet and writing events directly to the output stream for that. The Spring Boot does provide more convenient support through the use of a class called SSE emitter, and that can be returned as a return type from a controller endpoint. Now, these SSE emitters, they are returned once for each client. So if you have 1,000 clients connecting to your service, then you're going to be managing 1,000 instances of SSE emitters, and it provides a send method for sending data down that channel, if you like. Well, it's not actually a channel, and it also provides some callback methods to your code for when there's a connection closure or there's a client timeout. Okay, I'll move on to horizontal scalability issues in a minute, but first let's look at an example of this in action. I've put together a simple example here in an application that I'm gradually building up, and so I've added this SSE controller, which I'll go through in a second, and I've also created a very, very basic HTML and JavaScript front end to interact with this service. So let's look at the controller first. So it's annotated as a REST controller, and it contains some state because we have a list of the emitters. Remember, there's going to be one emitter for every client that connects. And there's going to be, and because we want to support reconnection, we need to keep a list of all the messages that we've sent. so that if a client misses some of those messages and asks to resend from the last event ID, then we'll be able to look at our records, see which ones that that client has not received, and then update it with the missing messages. So I've got two endpoints here and a utility method. So the first endpoint is subscribe. And so this is what the client will call when it wants to subscribe to these events. Now, so when somebody subscribes, we create a new SSE emitter, and we store that SSE emitter in our list of SSE emitters here. We're using a copy on write array list simply for basic consistency in a multi-threaded environment. So this will prevent us from reading something that's just in the process of being updated, because there's a copy on write. So we also do some basic handling of completion and timeout events. So if the client calls close on its event source, then we'll understand that that connection is completed, and so we'll remove this emitter from the emitters list. And similarly, if there's a timeout, we'll remove this emitter from the emitters list. And then finally, because we want to use the same subscribe endpoint for both subscription and also reconnection, because you can only configure one endpoint on the client side, we've got a quick check here that says if the last event ID, which is passed in via this header as a parameter, is not null, then we'll resend the missing events. So if this happens, then we'll look at how. Now the event IDs I'm using here just happen to be the indexes into my messages list. I think in reality, in a production situation, we would use a database or Redis, and we would store our messages in that, and then we would do a query to see which, based on the last event ID, do a query to pull out the subsequent messages. But in this case, we're just using an in-memory store. So we parse this last event ID, it becomes an integer, and then there should be extra handling or error handling on here, of course, but for a demo it's fine. And then we just simply loop over the messages from the last event up to the end of the message list, and we send those out via the emitter. And sending a message via emitter, we use this builder pattern. So emitter event produces a SSE event builder. We set the ID, because it'll be, let's say we're asking for events 7 through 10. We would say, give me 7, 8, 9, and then maybe the last one's 10. And yeah, okay, 0 indexed, of course. And we pull a message value and add that as the data, and that will get sent down the wire to our browser. A little bit of error logging there. And then, so the final question is, where do these events come from? So we've got clients registering, we've got the ability to send those events out. So where do the events actually come from? And the way we're doing it here, they could come from any kind of source. It could be Internet of Things data source. It could be positions of cars in our Uber network. It could be anything. Yeah. But in this case, we've got another endpoint, so the client can send a message to any client can send a message to us, and we'll broadcast that message out to all the other clients and also back to the sending client as well. So so that the client, any client, can send a post to this send endpoint, and we add that message to the messages list, and then we loop over all our SSE emitters, and finally, and those messages will be sent out to each of the other clients that are listening. Okay, so not too complicated. I think in production there would be some additional things to consider, where we store our messages, and certain things in terms of scalability, but that's the basic gist of it there. So let's look at our clients. So clients, a little bit of styling, but the actual structure is very simple. We have a button to subscribe. We have a section for and an input for messages that we want to send, broadcast back out to the other clients, and a send button. And we have a section for messages that are inbound from the server, from server-side events. And the code for this, again, is relatively simple. We're just attaching, to the buttons we've got, so the subscribe button, the message to send, the send button, and the messages inbound. We have a function to which we use when we receive a message to add a message to the received messages area. We've got the button to send. We've got the subscribe button, which is where we create our event source and we connect it up to the SSE subscribe. So that's the controller endpoint we have here. So SSE subscribe. Where am I? Oh yeah, okay. And then we say on message, we'll call this function, and this function just calls the add message, which puts it to the panel on the screen, which we'll see in a second. And then finally, the send button is simply taking the input value from the message and posting it to the service. And that's basically all that we need to do there. We just take the value, send it to the service, and the service posts it out to all the other clients. So let's run it and see if it works. Okay, so Spring Boot is running on port 8080, just there. So I'm going to open port 80. I'm going to open that in two tabs. Put them on the screen along with the console from Spring Boot at the bottom. And then let's do some simple tests. So I'm going to refer to the window on the left as window 1 and the window on the right as window 2. So we want to subscribe. We can see in the network tab, we've got subscribe there and subscribe over here. And the two subscribe requests have appeared at the controller. But with last event ID is null because they're not trying to reconnect. So let's type hello into this window. We get hello in both windows. We'll type, do it the other way around as well. Bye in this window. Get bye in both windows. So let's do a couple of experiments. So this time we can, let's take window 2 offline, and we'll start sending some events from window 1. So we'll say 1.1, so we know which window it comes from. Send. Is it really offline? I don't think it's offline yet, but it sometimes takes a second to update its behavior. 1.2. So now we're getting errors on the subscribe. So if I say 2.4, so 2.4 appears there, but so up to here we've got 2.1, 2.2, 2.3. Over here we've got 2.4, 2.5, 2.6. And now I'm going to bring this one back online again, and we'll see if it receives those missing messages. Okay, and there it receives the 2.4, 2.5, 2.6, and this is successful. I've got a success message as well there. So we can see that at this point, window 1 sent this last subscribe last event ID equals 9, and we said resending missing messages from 9 to 12. Okay, so that's a basic demo of SSE event broadcast and how we can handle disconnecting and reconnecting. Now, the actual reconnecting logic is wrapped up within the event source class itself. And this is important because there are different implementations of event sources in different browsers. And my testing of this with Firefox showed that it didn't want to reconnect when we did that experiment. So if you're going to be supporting multiple browsers, especially Firefox, but do your own testing on other browsers, you actually need to roll your own logic to do the reconnecting. It kind of works on Chrome, but for other browsers, just more general solution, you're going to need to actually handle the error that's coming out of this event source, and then do your own retry logic and keeping track of your own last event ID, which is I guess it's just part of the course in web development. All right, so that's the practical over there. I know this is dragging on quite a long time, so let's just quickly go back to a couple more things. One final thing that we need to consider is horizontal scalability. So in this setup, the browser is maintaining a persistent connection with your server. Now, a common solution for scaling any kind of web service is using horizontal scaling, i.e. adding additional servers and putting a load balancer in front of them, so that the work of additional traffic can be spread between more servers. The issue here is that since we have a persistent connection from our browser through to a specific server instance, we've got to maintain that communication channel. So when scaling this in production, we need to consider how we enforce session affinity between between the browser and the server instance that it's talking to. And this can be configured in load balancers, but it's an additional thing to make sure you get right. And then secondly, if we have a source of messages, we have to make sure that that source of messages is going to all of our server instances. So we can do that with something like a PubSub service, for example, Redis PubSub or Kafka or RabbitMQ or some other kind of messaging queue. And in that case, the messages would go through the load balancer to any one of our instances or from any other source. And that would be published on the PubSub queue, and all of the servers would listen to it. And since they would each be maintaining a subset of the SSE sessions, they would all be responsible for notifying their attached clients. So, okay, so that's a simple introduction to SSE. Hope it's useful. If you've got any points that you think I've missed, then I'd be very interested to hear them and learn from any comments you have. So thank you very much. Goodbye.